Hey guys, so this week we are going to learn about slope, which is also referred to as the rate of change. And our learning target this week is that we want to be able to find the slope or rate of change from a table, a graph, or 2 points. So what is slope? Slope represents the steepness of a line. You'll also hear the term rise over run, and we'll talk more about that as we go through. And then the change in y over the change in x. And you'll hear me say these things over and over again as the week goes through. There are 4 types of slope, and I'll also have an additional video that you're going to be watching today that focuses a little more on each type. But a positive slope goes up, a negative slope goes down. A zero slope is a horizontal line because since slope represents the steepness of a line, if you have a horizontal line, then there's no steepness to it. And then a vertical line, we call that undefined, okay? And so the ones you actually will be calculating are positive and negative slopes. And then anytime you see a horizontal line, you know it's a zero slope. And anytime you see a vertical line, you know that it is an undefined slope. So this is just like a little visual to kind of show you what different slopes look like. And you'll see the term m and in slope-intercept form, which we've briefly talked about. That is the m part of y equals mx plus b. Okay, and so you'll see, okay, here's a slope of 3, 2, 1, 1/2. There's 0, negative 1/2. You see the negatives are the lines that are going down and defines the vertical. When you're calculating slope from a table, it's pretty easy because you're just looking at the change in y over the change in x. And so when I look at this table right here, I'm going to look at my y values. So my y values go from 3 to 6 to 9 to 12 to 15. So my change in y is 3. And my change in x is 1, 2, 3, 4, 5, so it is 1. So 3 over 1 would be my slope, and you can reduce that down to just whole number 3. So anytime you have a table, you're just going to do my change in y over my change in x. And if it can be simplified, you'll simplify it. When you look at this table, so my change in y, we're going 5, 10, 15, 20, 25. So my change in y is 5. And then my change in x, if I go from 4 to 8 to 12 to 16 to 20, my change in x is 4. And so my slope is 5 over 4. Now 5 over 4, you might want to change it to a decimal or mixed number, but I say no to that because when you look at a graph, you want to look at the rise over run. And so you want to keep it in whole number form or in fraction form. And so you would just leave this slope as 5 over 4. Here's another table, and so we're going to look at the change in y over the change in x. And so if I go from 60 to 65, 70 to 75, 80 to 85, then I have an increase of 5. If I go from 20 to 40 to 60 to 80 to 100 to 120, I have an increase of 20. So 5 over 20 would be my slope, and then we know that that can be reduced to 1/4. So my slope would technically be 1/4 when simplifying it. Just another table. So we're going to look change in y over change in x. So 4, 7, 10, 13. I'm increasing by 3. 2, 3, 4, 5. I'm increasing by 1. 3 over 1 is a slope of 3. Change in y over change in x. Change in y over change in